Hello. In this video, we will go over the properties of a parallelogram, followed by two proof questions. So yeah, we're going to definitely go over some properties of parallelograms. So did you know that a parallelograms are nothing more than a special type of quadrilateral? Yes, it is. A parallelogram is a quadrilateral with two pairs of opposite sides that are parallel. Both pairs of opposite sides are congruent, and both pairs of opposite angles are also congruent. So this is how you know you have a quadrilateral. And then the fourth rule is the diagonal forms two congruent triangles. So yeah, so those are the characteristics of a quadrilateral, or a parallelogram is a quadrilateral. And then also the diagonals of any parallelogram bisect each other. So here's an example of a parallelogram. Parallelogram quadrilateral. So as you can see, this is definitely it looks like a rectangle, and one of the features says two pairs of opposite sides are parallel. So do you see these arrows right here? This means it's parallel. This side is parallel to this side. So whenever you see that arrow, that means parallel. And then they said opposite sides, so that means that this side right here, or this little arrow, is parallel with this arrow. So why keep in mind there's this one has two arrows and then this one has one. That means they're opposite. Okay. And they also say that opposite sides, it says two pairs of opposite sides are parallel. I mean, both pairs of opposite sides are congruent. So if you look at this side right here, this side is congruent with this side. And how do I know? Because it has this two tick marks. And then this side right here should be congruent with this side. And how do I know? Because it has this one tick mark. They aren't all four sides doesn't necessarily mean they are congruent, right? This only this side is congruent with this side, and then this side will be congruent with this side. So this might be, I'm just gonna make this up. This side could be five, and then this side must be five, and then this side could be two. That means that this side must be two. Okay. And they also said that diagonals, what did they say about diagonals? It says the diagonals form two congruent triangles. Is this true? So if you look at this diagonal here, right, this diagonal compare with this diagonal, do you see two congruent triangles? Yes, I do. Okay, and then the diagonals of any parallelogram bisect each other. Yes, it definitely bisects each other. Um, it also said both pairs of opposite angles are congruent. So if you look at our con angles, this angle right here is congruent with this angle only, right? They have to be on the opposite side, and then this angle here is congruent with this angle. Okay, so yeah, opposite angles are definitely congruent, and yeah, as you can see, line segment AB, I think I just went over that, but line segment AB is parallel to line segment DC, and then line segment AD is parallel to line segment BC. So this is parallel to this, and then this is parallel to that. And then we also said that the side lengths of opposite side are congruent, so line segment AB is congruent to line segment DC, and then line segment AD is congruent to line segment BC. That's not too hard to remember. I think the hard part is trying to remember that the diagonals. What did the diagonals do? The diagonals form two congruent triangles. So yeah, that's kind of hard to remember. So the diagonals form two congruent triangles. And the diagonals doesn't necessarily mean like the diagonals doesn't mean they're all equal length, right? So do you see this tick mark? Let's pretend this tick mark was a length of 3. That means that, and then you see this tick mark, that means this length has to be congruent with this length, so this is 3. And then do you see that this diagonal here, or this two tick marks, isn't going to be 3. It has to be something else, but it has to be congruent with this side length. So maybe this is 5, and then this could be also 5s. So as you can see, the diagonals are not all the same. So that's kind of something you have to remember because in a square, yeah, you'll learn about different other shapes and then they'll talk about their diagonals. So that'll distinguish yeah, that'll distinguish it. And then yeah, angle A is congruent to angle C. Yeah, so opposite angles are congruent. So this angle is congruent with this, and then this angle is congruent with this angle. Okay, let's look at this example. So now you know some of the properties. Use the properties of a parallelogram to complete the statement. So we have this parallelogram, and we want to know some stuff. So I'm saying, how do we know why is this considered parallelogram? Because we have two sides. So we know that two parallel sides are par two opposite sides are parallel, right? You see it, this two arrow is parallel with this, and they're also congruent. So this side is congruent with this, and then this side is parallel with this side because there's one arrow, and then this side is congruent with this, and opposite angles are congruent. So this angle is congruent with this, and then this angle is congruent with that. And then the diagonals doesn't necessarily mean they're the same, equal length, right? This line segment JN is congruent with NL, and then KN is congruent to NM. So as you can see, the diagonals are not equal length. So we got to answer some of these questions. So what do you think line segment JK is going to be? So here, we're first locate line segment JK. It's right here, right? So what side is it congruent with? Yes, ML, line segment ML. And order does kind of matter. I think it would be wrong if you say LM because it started from J to K, so you have to do the same order. Okay. What about number 2? Line segment MN is congruent to what side line? Where's MN? This. So it's like a diagonal, right? What do you think a line segment MN is congruent to this? Yes, this line segment. Do you see how they have one tick mark? That means that this tick mark is congruent with that tick mark, and that would be line segment KN, right? Line segment MN is congruent to line segment KN. Okay, let's move on to number 3. What do you think angle MLK is congruent to? So first locate angle MLK. So MLK. So this angle right here. What do you think this angle is congruent? So according to the rule, opposite angles are congruent. So it would be this angle here, angle J, but we can also express angle J as what? JML. So it's still JML is the same thing as angle J. So JML. Okay. What about 4? What do you think angle JKL is going to be? Let me see if I can zoom out so you can still see the image. I can't zoom out. I forget how, so. Okay, so we'll just have to scroll back. So, what is number four? It says find angle JKL, or what do you think angle JKL is going to be congruent with? So first locate JKL. So at this angle right here, and we said that opposite angles are congruent, JKL. So it's congruent to angle M, but how can we express angle M? JML. So yeah, this is congruent to J angle JML. Okay, number five. Uh, what do you think line segment JN is going to be congruent? So where's JN? So it's this little diagonal that is congruent with LN, this side length, right? So that would be JN. This is, yeah, LN. Okay, what about six? Line segment KL. K, where's KL? This diagonal is congruent to this opposite side, so JM, right? What about seven? What do you think angle JNL is going to be? JNL. Angle J, I mean, not JN, MNL. So MNL. Ooh. Yeah, what do you think? MNL. Okay. Right, so they kind of J M N L is this angle, and it kind of forms like vertical angles, so it's congruent with this angle, right? Because all vertical angles are congruent. So that angle right there, right here, could be expressed as K and J. K and J. Because vertical angles, right? And then what do you think angle MKL? So MKL. Oh, ooh, that's different. This is number eight, MKL. MKL. So notice it's not MK, it's this little angle right here. Um, that is, so if you kind of like expand this, right, and then expand this, um, this angle right here, you see this little angle right here, would be congruent to, uh, I believe this angle, this smaller angle. And why is that? So this angle right here, how would I express it? That would be KMK. It would be expressed as KMJ. KMJ. Yeah. So this angle right here is congruent with this angle here. And the reason why is because of alternate interior. So angle MKL is congruent to KMJ. And the reason why is because alternate interior angles. Okay. So look, I mean, so if you like expand this, these are two lines are parallel. And then if you expand this line, this would be like your transversal. So they're on the opposite side of the transversal, so that makes it alternate interior angles. So that was something from geometry. Okay, so let's move on. So here we have this parallelogram, and we got to find a few things. So we have this parallelogram, and what did they tell us? That they tell us that this side length LMN is 8. They tell that this side length PM is 8.2. They tell you that this angle here is 29. This angle here is 100. This angle here is 100. So they want to, number 9 says, find the length. What is the length of LM going to be? So first locate LM. So LM is this length, and that would be congruent to QN, so that would be 13. What about the length of LP? LP is, where is LP? This length here. Ooh, that's different. Uh, what do you think LP would be? LP. Oh, that's what this was given 7. So the length of NP is 7. So that's going to definitely help. So remember, these diagonals are congruent with this time. This side length is congruent with this side length. So that concludes that LP also should be 7. Okay. And then what do you think number 11 is going to be? Length LQ. So where's L and where is Q? This length here. So LQ is parallel with MN, and then we know that parallel sides are congruent, so LQ is 8. Number 12, what do you think the length of QP? So where is QP? QP is this length right here, and they tell us the length of PM is 8.2, so QP should also be 8.2, right? These two side lengths are congruent. Oops. So QP should be 8.2. Okay, 13. What do you think angle LMN is going to be? LMN. So here's L, here's M, and here's N. LMN. So this entire angle right here. Hmm. Well, I know that angle L or QLM is 100, and because the angle of M and Q is also 100. But what is angle? What do you think angle NQL is going to be? NQL. N NQL. Wait, what number? Oops. Number 13. So what do you think angle LMN is going to be? So LMN. LMN. Uh, okay, so what do we know is opposite angles are congruent. And I think I also believe that this is going to, so if you look at this angle plus this angle here, yeah, so this angle plus this angle is supplementary, so that means they add up to 100. So 100 plus uh this angle. So we don't know what this tiny angle is, right? We don't know. We can call it x plus 29, and that equals to 180. So let's find this angle. So that would be 100 plus, what's 100 plus 29 plus x plus 180? So that's 129 plus x equals 180 and 129. 51. So yeah, 51 here. So this tiny angle is 51, but if you add these two angles, 51 and 29, what does that give you? 80. So this entire angle here should be 80. Yes. So yeah, opposite angles are congruent, but these if you add up these two angles, they are supplementary, meaning they add up to 180. So yeah. So LMN is 80 degrees. What about 14? What do you think angle NQL is going to be? NQL. NQL. So it's this entire angle, and that's congruent with LMN. So that should also be 80 degrees, right? Because opposite sides, I mean, opposite angles are congruent. Okay, 15. What do you think the angle MNQ is going to be? MNQ. MNQ. This angle. So this entire angle is 100 because that was given. And then 16, angle LMQ, LMQ, LM. Oh, so this tiny angle right here. So do you see this angle? That should be congruent with this angle, right? Because they're alternate interior, alternate exterior. They're on the opposite side of the transversal, so they're congruent. So this angle should be congruent with this tiny angle here, so that is 29 degrees. Okay. Okay, let's move on then. Example 3 says find the value of each variable given the parallelogram. So we have this parallelogram. We have a few things. We have a side length of 14, an angle of 101, and then another side length of 10. We got to find the length of y. So y is parallel with 14, so that means it's congruent. So y should be 14. What about the side length of x? So side length of x is also parallel with 10, and they're also congruent. Okay, what about angle A? So angle A is opposite from angle 101, so we know that opposite angles are congruent. So angle A is 101. And then angle B, um, we don't know what angle B is. We don't know, they didn't give you this angle, but we said that if you add up this angle plus this angle, they're not congruent, but they're supplementary, meaning they add up to 180. 180. So 101 plus angle B is equals 180. And then when you subtract 101, you get angle B is going to be 79 degrees. Okay, so yeah, these two angles are supplementary, opposite angles are congruent. Okay, so what about this parallelogram? We need to find the length of x and the length of y. So they don't give us any angles. They give us, if you look at the diagonals, they give us some lengths of only the diagonals. So we need to know what x is, and we need to know the length of y. So what do we know about side lengths of the diagonals? We know that this side is congruent to this side, and then we know that this side is congruent with this side. Okay, so let's find x. So it would be 2x plus 2, this side, is equal to this side, 5x minus 10, right? And then go ahead and solve for x. You're going to subtract 2x, get 2 equals 5x minus 2x is 3x. minus 10, and then add 10. 10 plus 2 is 12, equals to 3x, divides by 3, x equals 4. So yeah, my x is going to be 4. What about the length of y? This length is equal to this length, so y over 3 equals to 6, or 6 over 1. So you can solve for y, you can cross multiply, so this would be y, and then 3 times 6 is 18. So that means y is 18. Okay, so not too bad. Okay, let's move on to the next example. Okay, so this one says, for each value of the given parallelogram, we have parallelogram ABCD, ABCD. We got to find the length of M, N, and P. So M is an angle, N is, I believe, also an angle, and then P is also angles. So they're all angles. So what do we know about angles in a parallelogram? Opposite angles are congruent. So we know that angle A is, or this angle here, is congruent to this angle, and then angle B is congruent to angle D. So would that even help? So if we kind of set it up, we would say M equals to N plus 10, and then our other equation could be expressed as N minus 10 equals to P. That is not going to help out. Um, yeah, that's not going to help. Why is this not going to help? We need one of the letters, right? So what else do we know about angles in a parallelogram? These angle A plus angle B is supplementary, or you could think of it as same side interior. So if you kind of wrote, oh, I'm sorry. Um, so if, yeah, angle A plus angle B is 180, but that won't work, right? Uh, I just thought of it like, right, if you add up angle A, which is n minus 10, if you add up angle B, which is m equals to 180, that's not going to help. The same thing with C and D. If you add them up, it would never, you would never figure out what it would be. Imagine rotating this parallelogram 180, right? Imagine rotating it. Now these two angles are same side interior. So you could also say n minus 10 plus this angle D. So angle A plus angle D are also supplementary or same side. So you could say n minus 10 plus n plus 10 equals 180. Let's see if that helps. I think that will work because 1n plus 1n is 2n. Negative 10 plus 10 cancels, and then you're left with 180. Solve for n by dividing those out by 2. And you get 180 divided by 2 is 90. Okay, uh, that is very helpful. So now we can figure out what this angle is. So we know that n is 90. So now we could figure out what angle M is and angle P is. Angle P is congruent to angle n minus 10. And we know what that is already. So it's going to be, so we know that n minus 10 is equal to angle P. And we know that n is 90, so 90 minus 10 equals to P, and then 90 minus 10 is 80 equals to P. So P is equal to 80 degrees. They're all degrees. And then what do you think angle M is? So we know that angle M is congruent to angle n plus 10. So that means M is equal to N, which is 90, plus 10, which is 100 degrees. So angle M is 100 degrees. Okay, let's move on. So this one we have some kind of we have a two-column proof we have to do. So here we are given that parallelogram ABEF and parallelogram BCDE are parallelograms. Prove that line segment AF is congruent to line segment CD. So we got to do a two-column proof, and I think I'll put it on the side of the right side, on this side, because so you can see the image. So yeah, we're gonna use a two-column proof. So this will be statement, and then this will be reason. So statement one, I always use what they give us. So statement one, we could say that ABEF and BCDE are parallelograms because that was given. So you could say ABEF and BCDE are parallelograms. And the reason is because that was given, right? Okay, let's do the next one. We could say that AF, so there should be AF is congruent to BF. I mean, AF is congruent to BE. Yes. Do you see? I actually see three parallelograms, but yeah, we could say that line segment AF is congruent to line segment. There should be a B here, B BE, right? And what else could we say? 'Cause you see how you have these two arrows, that means they're parallel. Parallel, that means uh parallel sides are also congruent. So we could also say BE, line segment BE is congruent to line segment CD, right? See, these two arrows means they are congruent. Okay, wait, is that right? Yes. A line segment AF is congruent to line segment BE, and then line segment BE is congruent to line segment CD. And what would be the reason? Opposite sides of a parallelogram are congruent, right? Remember when we were going over the properties, we said that opposite sides of a parallelogram are always congruent. So you could say, okay, step three. Um, what else could we say? So how to prove that line segment AF is congruent to CD? So I think our last statement would be the proof. We could say that line segment AF is congruent to line segment CD, and the reason will be transitive property. AF. Yeah. So the third one will be we just proved it, which is the transitive property. Okay. Uh, I guess we could do, I think we have one more quiz to do. Okay, so if you look at this proof, this it says given JKLM is a parallelogram, prove that angle J and angle K are supplementary. Angle J, angle K are supplementary. So yeah, so I think we gotta first prove it's given is a parallelogram. So yeah, let's start with so we're gonna do a two-column proof. So this will be statement, and then this would be reason. So let's start with the given. We always start with the given. So it was given that JKLM is a parallelogram. So you could say statement where JKLM is a parallelogram, and that's given. Okay. What about our angles? What angles do you think is congruent? Well, we know that opposite angles are congruent, so that means that angle J is congruent to angle L. So we know that this angle here is congruent to this angle. And what other angles do we know is congruent? Angle M is congruent to angle K. And the reason why we said that opposite angles in a parallelogram are congruent. Okay, statement three. Um, what else do we know about angles in a parallelogram? So if you add up all four angles of this parallelogram, we know that they will add up to 360. So if you add up angle J plus angle K plus angle L plus angle M, they all add up to 360. And that will be the sum of interior angles in a parallelogram. That's 360. And you can also switch this around. So statement four, we could also say that if you add up angle J plus angle M, so J and M plus angle J and M. So if you add up this angle plus this angle, and then if you add it up again, it all equals 360. So the reason is substitution property. Okay, not quite done yet. More on angles. We can also say for statement 5, if you do 2 times angle J plus angle M, uh, that would equal to 360. And then that would be the distributed property. Or I mean, if you got rid of the 2, and then angle J plus angle M equals 180. So if you divide this by 2, this would be just angle J plus angle M is 180. So that would be distributed property. There's 6. We can also say that angle J plus angle M. So if you, yeah, actually, before you divide this by 2, if after you divide this by 2, you're going to get angle J plus angle M equals 180 degrees. That is called the division property. And then you can also say more, for more of the angles, you can also say that angle J plus angle K is 180 degrees, and that would be substitution property. And lastly, we could say angle J and angle K are supplementary. Well, I think that's the last statement. We have to prove that angle J and angle K are supplementary, and that's the last statement. So angle J and angle K are supplementary. And the reason is definition of supplementary angles. Okay. So yeah, that would be the last statement. And the next video should be about how to prove a parallelogram. So we went over properties of parallelogram. Now we're going to talk about how to prove a parallelogram. Okay, yeah, we're going to stop here.